Today I'll talk about how to select an appropriate machine learning algorithm. This is part of my series of lecture on machine learning. Machine learning algorithms can be divided into supervised, unsupervised, and reinforcement learning. Supervised learning includes supervised single learner. The problem may be classification or regression. Supervised ensemble methods. The problem may be classification or regression. I have a separate lecture on ensemble methods. Then the supervised situation may be forecasting or anomaly detection. Anomaly detection include predicting a credit risk, detection of fraud, or catch abnormal equipment reading. Here the two algorithms which can be used are PCA-based anomaly detection and one-class SVM. I have selected few machine learning algorithms to describe their salient features, which will help us in selection of appropriate algorithm for our machine learning problem. So machine learning algorithms may be linear models, decision tree, support vector machine, k-nearest neighbor, classifier and regressor, deep learning, also known as neural networks, and k-means clustering. K-means clustering is a type of unsupervised machine learning situation, and the initial ones are supervised machine learning situation. First of all, let us see what are the salient features of linear models. These include linear regression, logistic regression, and many other algorithms. They are linear in nature, that is, there is some kind of linear relation between input features and outcome variables. They take less time to train. They algorithm have high bias and low variance. Decision tree, they have non-linear nature. They take more time to train. However, they are very simple to interpret. They are used in many ensemble methods. The unpruned trees have low bias and high variance, whereas tree stumps, that is decision tree with single level, they have high bias and low variance. Support vector machine, they may have linear as well as non-linear nature. The linear SVM have high bias and low variance, whereas the kernel SVM or non-linear SVM, they have low bias and high variance. K-nearest neighbor, classifier and regressor, they are non-linear in nature. They keep entire training set in memory. K-nearest neighbor algorithm or model with high value of K will have high bias and low variance, whereas if K is set to a low value, for example, K is equal to 1, then our model, the algorithm have low bias and high variance. Neural network, their overall nature is non-linear. However, at a particular node in a neural network, there may be some kind of linear function. They take more time to train. They are more accurate than interpretable. They are very useful for learning related to text data and image data. K-means clustering, it is a type of unsupervised learning. It has excellent accuracy. It takes more time to train, and it has a linear nature. Now let us see how to select an appropriate algorithm. What are the points to be taken into consideration? The first point is type of problem. Our algorithm depend on type of problem. The problem may be regression problem, classification problem, forecasting problem, or anomaly detection problem. The second point to be considered is relation between input features and outcome variable, which may be either linear or non-linear. The third point to be considered is amount of training data. If there are fewer observations and large number of features, for example, in genetic and textual data, we should use algorithm with high bias and low variance, and these include linear regression, naive linear SVM, KNN with high K. When we have large number of observations and fewer features, then we should use algorithm with low bias and high variance. These include decision tree, kernel SVM, KNN with low K. Then the other point to be considered is interpretability versus accuracy. The interpretable algorithms are easy to understand. We can easily understand the relation between input feature and outcome variable, example linear models, whereas the accurate algorithm, the output is close to true value. For example, K nearest neighbor with K is equal to 1, neural network, unpruned decision tree, gradient boosting method, kernel SVM. Interpretability is inversely related to accuracy. These two are inversely related. Then this is the final point which should be taken into consideration, time to train our model. Actually, model is combination of algorithm plus data. So less time to train the algorithm into linear models and naive-Bayes, more time to train the algorithm into support vector machine, neural network, decision tree, random forest, etc. So what are the steps in algorithm selection? First of all, we should define the problem, which may be of these type, as I told you before. Then we should explore our data. That is, we should see that how many number of observations are there, how many number of features are there, whether there are more observations than features or more features than observations. We should also try to identify relation between outcome and input features, whether it is linear or non-linear. And we should start first with basic algorithm and then try complicated algorithms. So this is all for today. I hope this video will be very helpful to you. Thank you very much.